Example 4. Find the exact value of each expression. In part A, we have the sine of 5 pi over 9 times the cosine of pi over 18 minus the cosine of 5 pi over 9 times the sine of pi over 18. All right, your first thought might be, well, let me just plug this into the calculator and get the answer. And the issue with that is that when you plug this into your calculator, you're going to get a nasty decimal. And it's going to be a decimal that you likely cannot convert to a fraction. So you're not going to be able to get an exact value by popping it into the calculator, so you can't do that. The other issue is the angles. Okay, we're dealing with 5 pi over 9 and pi over 18, and those two angles are not on the unit circle. So evaluating their trigonometric functions is going to be difficult. Okay, however, to do this, we can apply a sum or difference identity. If you look at this, we have sine times cosine minus cosine times sine. And if we go back to our sum and difference identities back on page 1, okay, we can match this up with this equation, okay, in number 4, okay, because you have sine times cosine minus cosine times sine, okay. So I'm going to go back to my page here and I'm going to jot this down, okay. We know that the sine of A minus B is equal to the sine of A times the cosine of B minus the cosine of A times the sine of B. All right, this is like a template for what we have. Okay, again, it's sine times cosine minus cosine times sine. Okay, so what this is doing, okay, if we write down or if we look at what we have, okay, we have the sine of 5 pi over 9 times the cosine of pi over 18 minus the cosine of 5 pi over 9 times the sine of pi over 18. Okay, it's matching up exactly, and we're seeing from this that the A value here is 5 pi over 9 and the B value is pi over 18. Okay, so we've got the right side of the equation filled in. Okay, so if we go backwards to the left side, this is going to be equivalent to the sine of the A value, which is 5 pi over 9, minus the B value, which is pi over 18. Okay, so all we need to do is simplify this guy. Okay, what is 5 pi over 9 minus pi over 18? Okay, well, I'm going to come over here and figure out what that angle is. Okay. All right, so we are subtracting two fractions, so we need a common denominator. So out of 9 and 18, we're going to pick the bigger one here. We're going to make these two fractions over 18 that we're subtracting. The right fraction already has the correct denominator, so we're going to keep a pi in the numerator. We're not going to change it. But on the left fraction, to get a denominator of 18, we need to multiply the 9 by 2, so we need to do that to the top. So the numerator is now going to be 2 times 5 pi, that's 10 pi. Okay, and so now we've got two fractions over 18. We can subtract, keep the same denominator, subtract across the top. 10 pi minus pi is going to be 9 pi. 9 pi over 18 reduces to pi over 2. Okay, so now we know the angle. Okay, so I'm working backwards here. Okay, so we know the expression that we started with is equivalent to the sine of 5 pi over 9 minus pi over 18. But if we combine those fractions, that's equivalent to the sine of pi over 2. Okay, and we know the sine of pi over 2 is what? Okay, well, sine of pi over 2, here's pi over 2. The sine value is going to be 1. Okay, so the answer to this whole thing is 1. Okay, so actually, if you did pop this one into the calculator, you would get an exact answer. But you do have to be concerned about the situations where you pop it in and you get a nasty decimal. Okay, so you do have to know how to handle this in that event. Okay, all right, let's try the one in part B. Okay, part B, the expression is the tangent of 80 degrees minus the tangent of negative 55 degrees all over 1 plus the tangent of 80 degrees times the tangent of negative 55 degrees. Okay, again, the same thing. You know, if you pop it into the calculator, you could end up with something ugly. So let's just, learn how to use the sum and difference identities to evaluate this. Okay. All right, first thing I want to do is handle the negative angle. Okay, so if I have a negative angle, sometimes that can just kind of throw you off, but don't let it. You can use those even and odd identities. Okay, we know that tangent is an odd function. Okay, so if we have the tangent of a negative argument, we can pull that negative sign out front. Okay, so the first thing I'm going to do here is use the odd property of tangent to get rid of the negative argument. Okay, the expression, I'm going to rewrite it. This is going to be the tangent of 80 degrees minus, okay, this minus goes right here. Okay, and then I'm going to take out this negative and bring it out front. Okay, so we're going to be subtracting a negative tangent of positive 55 degrees. Okay, I'm going to do the same thing in the bottom. The bottom is going to be 1 plus the tangent of 80 degrees. Okay, I'm going to take this negative sign right here and bring it out. Okay, so this is going to be tangent of 80 degrees times the negative tangent of positive 55 degrees. Okay, if I simplify this, in the numerator, we are subtracting a negative. So it's going to become the tangent of 80 degrees plus the tangent of 55 degrees. And then the bottom is going to be 1. We have positive times negative. That's going to be 1 minus the tangent of 80 degrees times the tangent of 55 degrees. Okay, so now we're left with positive arguments or positive angles. Okay, and we can match this up with one of the identities for tangent. Okay, so we are adding in the numerator and subtracting in the denominator. So if we go back to page 1, this is going to match up with identity number 5. Okay, where we are adding in the numerator, subtracting in the denominator. Okay, so let's go ahead and jot that down. Okay, so we know that the appropriate formula here is going to be that the tangent of A plus B is going to be equal to the tangent of A plus the tangent of B all over 1 minus the tangent of A times the tangent of B. Okay, like I said, this is exactly what we have. Okay, if you kind of match these guys up, what we have here is that our A value is 80 degrees and our B value is 55 degrees. Okay, so if we are working this, okay, like I said, we have tangent of 80 degrees plus the tangent of 55 degrees over 1 minus the tangent of 80 degrees times the tangent of 55 degrees. Okay, it's lining up exactly with what we have in red, so we're going to work it backwards. Okay, with A being 80 degrees and B being 55 degrees, this is equivalent to the tangent of A plus B. Okay, so the tangent of 80 degrees plus 55 degrees. Okay, if you add these two angles, 80 degrees plus 55 degrees, this is going to be the tangent of 135 degrees. Okay, and now we can revisit our unit circle and we can look at 135 degrees. Okay, so if we're looking at 135 degrees, here's the point on the unit circle, okay, that we need to look at. Okay, so to compute the tangent, we need to do the y coordinate divided by the x coordinate. Okay, so if we do that, okay, this is going to give us the square root of 2 over 2 divided by the negative square root of 2 over 2. Okay, so anything divided by itself is going to be 1, so we're going to end up with -1 here, and that is our value. Okay, again, this was a nice answer. If we had popped this in the calculator, we would have ended up with -1. Okay, but we're learning to do it this way in the event that, the expression that we're dealing with produces some kind of ugly decimal in the calculator. Okay, we know now how to match these expressions up to one of the sum or difference identities, and then we can go from there.